So welcome to ACS Victoria's February Member Forum, which is the first member forum for the year. My name is Maria Markman and I'm the chair of ACS Victoria. Before we start tonight's event, I would like to acknowledge the traditional custodians of the land on which we are meeting and pay my respects to their elders, both past and present. So tonight's member forum is on responsible AI, building a fair, inclusive, explainable, ethical and safe AI. Recently awarded ICT Professional of the Year at the 2018 ACS Digital Disruptors Awards, Darren Velu is an experienced AI professional and a tech-savvy business leader. He's avidly focused on guiding large enterprises and organizations in adopting cognitive computing and AI technologies to implement innovative and game-changing solutions. He helps strategize, design, and lead the future expansion of the AI and cognitive platforms across multiple industry verticals. As a former IBM Watson Cognitive Solutions lead, Darren has been a key contributor to some of the earliest AI implementations in Australia. So please join me in welcoming Darren this evening.
Its first birthday. It exceeded our wildest expectations.
Nice to meet you, Morgan.
Nice to meet you, Lee.
I have a 13-year-old daughter. You don't get to see her much anymore.
Skip, don't go in there, okay?
Don't what?
Don't you go down there, Skip.
Don't be afraid, Amy. I have to go say goodbye to Mother.
How many recognize that movie? That's the official trailer of a movie called Morgan, a dark sci-fi, horror, eerie AI movie. Just like everything AI in Hollywood sticks to the theme. What's fascinating about that movie is not the theme, but what's fascinating is that trailer that you just saw was completely created by an artificial intelligence. There were no humans involved in creating that piece of video. So 20th Century Fox approached IBM and they asked them if they could create a trailer for them using their AI platform, Watson. And what Watson did was it ingested the entire movie and it started to analyze the movie. So the video part of it was taken off, sliced into images, and the images were recognized and analyzed frame by frame, looking for facial expressions, looking for sentiments in the images. You know, what's sad, what's fearful, what's eerie, and then the audio cues, the background score that you saw was also analyzed for what resonates most with fear, what resonates most with shock, and so on. The dialogues that you heard were also analyzed through a language processing engine. And similarly mined for insights, sentiment insights from language. And all of that was put together by a machine automatically. And what the machine thought is going to be a good trailer that sort of conveys the essence of the movie. Now that's what's fascinating about this, and that's what's always sort of fascinated me in this subject. So I specialize in a subject called artificial neural networks at university, long time ago, but we never got to use it. We never got to use it because AI it didn't work. It wasn't very practical. Now it is the topic in the technology world. We're seeing so many applications that are out there, and we're reading about them. It's in the news. And what I think has made that happen, why we think AI is a viable technology option today, is because of these three factors. The first one's data. We're producing so much data today, right? With all the devices that we're using, we're producing so much data today. 90% of the world's data was produced in the last 2 years, right? And if you know anything about AI systems and how they work, they are data hungry. You got to feed this beast lots of data for it to make sense and start to make patterns out of data. And today we have that data, we have that fuel to feed these AI systems. And another factor is computation. The fundamental concepts of AI hasn't changed from a long time. That's always been the same. But data and computation coming together is making all of that practical and more possible today. We have access to almost unlimited computation on the cloud these days. We started with CPUs, and then we went into graphical processing units, GPUs. GPUs are primarily used for image processing and video processing in sort of that world. But then it was a really good architecture for parallel processing. It just suited so well for everything we do in the AI world with machine learning and stuff. So computation, accessibility to cheap and powerful computation is another factor that's sort of accelerating the trends in AI. And the last one is algorithms. We are producing enormous amounts of algorithms in all areas of AI. And these algorithms are coming out from research labs that are heavily funded. So lots of money is going into labs to create these algorithms, but these algorithms are coming out as pretty much free. These are all open source algorithms. And so in my work, every time we figured out a way to do something using a certain algorithm and a certain architecture, I'll have one of my data scientists coming and telling me, you know what, there's a new algorithm that, let's say, Google DeepBrain published yesterday, and it's just a game changer in what we are doing. So we're going to quickly adopt that, and we're going to sort of see how that works for us. And that's an ongoing thing. We're seeing really powerful algorithms, game-changing algorithms by the day. These three is what I call the AI trinity. And that's what most researchers and most experts say. And we were in an AI winter in the past, and now we're sort of coming to the AI summer. Things have started to work. We've spent a lot of time getting this to work until now. And now is the time we're saying, okay, how do you get this to work properly? How do you get this to work ethically and responsibly and morally? Some economists call this technology as a general purpose technology. General purpose technology in the past would have been internal combustion engines or steam or electricity. The point about general purpose technologies is not just the direct contribution they have to the society, but also all the spillover innovations that happen from general purpose technology. Andrew Ng from DeepBrain made this famous statement calling AI as electricity. If you come to think of it, what we did with electricity, we were able to create power, we were able to store it, and we were able to distribute it to where it was needed. So if there was a farmer in the farm and using a mechanical pump to pump water, electricity could be distributed to the point, and the farmer could apply electricity, and now he has an electric pump, right? So we were able to just transport power. And what power did to strength and physical strength is what AI will do to our intelligence. Today we're able to create AI, synthesize it, we're able to store it, and we're able to distribute it. AI as a service. So you could go and consume AI 6 cents a hit from a cloud provider today. All right? And that's exactly what the revolution will set forth. There's a subtle concept here. With this synthesized AI, with this intelligence that we've created, we can now sort of put them together, we can cluster them together and start to scale them as well, right? And that's a concept called collective intelligence. And collective intelligence is a very powerful concept. Let me explain. So that's a Tesla Model X braking before the accident is detected, right? I'll play that video again, and just pay attention to around 4 seconds mark in the video. It starts to beep and warn the driver before the actual accident happens. A few seconds, microseconds before, or a few seconds before the accident happens. Now, the AI that's powering that has come to a conclusion that an accident is going to happen, and therefore it has predicted that and they're warning the driver. It does this by looking at the scene around. So there's a little bit of a swerve of one car, there's tail lamps going on another car, and it stabilizes itself, and the braking of that car is probably much more stable than the braking of other cars. I'm going to play that video again. So there's a lot of processing happening there. There's a lot of processing happening there in very little time. Can you see that dot in the middle of the screen? That represents your lifetime worth of driving knowledge. Okay, let's say you've been driving for 60 years, and you've driven approximately 700,000 kilometers, let's say, right? And that is Tesla Machines' crowdsourced knowledge in less than 15 years. That's the power of collective intelligence. Right now, we can not just create intelligence, we can put them together. We can just bring in a lot of learnings from many people and put them together and collectively apply it. So what makes AI so different to what we've been doing in the computing world? Right? If you come to look at it, let's take traditional computing. You have a set of inputs, and then you want to achieve a certain outcome, and then therefore you write a program that will work on that input, and you feed it to a computer, and the computer generates that output, right? So if you had an input A and the output, and you wanted an output B, and if that doesn't happen, there's a problem with your program, you go and fix it, you debug it, and you run it again, right, until you get that output. And that's static, that doesn't change. So when you come back the next day and give it the same inputs, you have to get the same outputs. Otherwise, there's a problem in your program. There's a problem in your program or the way it's being computed, right? This is, in the machine learning world, it's slightly different. You have inputs, and then you have outputs. You have sample outputs. So you're going to tell the machine, here are some outputs that I've had in the past. Look at it. Make sense out of this. Learn from this. And then why don't you create a program for me that I can use in my application, right? So it takes inputs and it takes sample outputs, sample data, sample results from previous, and it learns from that. And with that new program, you could feed it an input, and then it gives you an inferred output. That's the fundamental concept to machine learning. And that output there can change. You can feed it a little more output, you can feed it a little more about what happened in the past, and the computer rejigs the program, and then you can ask new questions. Right? That's a very simple explanation of machine learning. If there are data scientists in the room, they're just going to hate me for this way of explaining machine learning. Right? There's another very powerful, in the more modern AI world, there's another very powerful technique called deep neural networks. Loosely sort of built on the concept of how our brains work or how an animal brain works. So the way we do computations is we've got neurons, millions and zillions of them, and then we have to perform a complex computational task. These are split into micro-level tasks, and each neuron is just working on one specific task. And they coordinate with other neurons, and then collectively they sort of do a higher-level task, and so on. They just go to the full-level computation. Using that concept, neural networks were created. So what you see there are those little circles there are computer nodes, and each of them is doing one, let's say, a really simple micro task. And they're working in coordination with other computing nodes, and together they're doing a subtask. And these neural networks can form layers, and then you can put them layer on layer on layer. So let's say a deep neural network is tasked with recognizing a human face. So some nodes in the network is looking for edges on your face, and the other one's looking at eyeballs and making sense if that's an eyeball, and all of them are put together and say, oh yes, that looks like a face. I can see all the features here, and therefore I'm going to call this a face. So it goes through layers and layers of processing, each little node there just doing one specific pattern recognition in that case. That's a very simple representation. It looks something like that. Many more layers, much more spaghetti connections than that. But that's how a deep learning network works. Machine learning and deep learning are the coolest things in the market today. So if you're in the technology space, instant coolness is using the word machine learning and deep learning and associating yourself with that, right? It is. I'll tell you how cool that is. I found that one. There's an AC/DC version, a logo for machine learning and for deep learning. That's cool. On a much more serious thing, so deep learning has brought in some amazing, jaw-dropping applications in the market. Every day we come across things that we go, how on earth did that happen? How did someone go about doing that? But I can talk all day about deep learning. It's a subject very close to my heart, and I'm spending a lot of time researching in that space at the moment. But I'm going to take two examples. I'm going to take one example in the language processing and one example in the image processing space, right? Both deep learning applications. How many of you all have heard IBM Project Debater? Anybody in the room? Oh, there's one. Awesome. This is the bee's knees in language processing. This is the best possible application of natural language processing that we've done today. So what IBM Project Debater is, it's the first AI that can actually hold a debate with humans on complex topics, right? I'll try and explain that a little more, right? So this machine, if you put it in a debate scenario, so let's say there were two humans debating on a certain topic, the machine quickly understands what the topic of debate is, and then starts to construct opposing statements or rebutting if it needs to rebut. It accesses a large corpus of information, identifies a topic, and then places in statements, well-constructed statements, right? So just let's quickly go through the kind of technologies or the kind of computation that's happening in the back end. Firstly, it has to understand voice. There's something there that's transcribing voice to text. And there is something that is processing the text and understanding language and the semantics in the language. And then something is accessing a large corpus of information, possibly something like Wikipedia, because this is general knowledge. The topic can be anything. And then once it understands that's the topic these two humans are talking about, and then it starts to construct its position and its stance. And then it generates the language in text possibly, and then converts that into speech and synthesizes it into speech and then delivers it as a speech. I've seen this thing work. I know two people from this department who worked on this for many years. This is mind-blowing. You can actually Google IBM Project Debater. Every data set that was used here, every architecture that was used here is open source. People can just go and, if you fancy getting a little technical, you can go and understand what's happening there. There's the fundamental thing here is a concept called machine comprehension. It's a much more newer topic in the AI world. Machine being able to comprehend a certain scene or a certain environment, right? On Monday, I think February 11th, you can actually tune into a live debate where Project Debater takes on a very high caliber debate with the former European champ. So just go Google it, and you can actually tune in and watch it live. I've seen some of this. There's some of this on YouTube videos. It's fantastic. It actually asked someone to talk slow. It said, you're talking too fast, and there's no need for you to talk so fast, so talk slow. It just literally just shuts people down. It's fantastic. I suggest you go and read about this. So that's how far we've gone with processing language. It's a great feat. It is still experiment. This is still from a lab. It's still rough around the edges. I don't think you can put this to practical use as yet, but this is where we are heading, and this is where we are today. How many recognize that? Do you know what that is? No one? 1, 2. That's Google Clips. It's a new little device. It's probably on sale it's on sale on the Google American website. I don't know if it's in the Australian website, but it's a 2-inch by 2-inch camera, and what it does is it takes pictures. It introduces a concept called automatic photography. So it stays on in your living room, and it looks at what's happening all the time, and then it finds out what's an interesting moment and then takes a picture of it or makes a short video, a 7-second video of it. Now the camera decides what's interesting, right? It understands the scene and says, oh, I think they're about to cut a cake. That must be a birthday happening, and I think I must capture the cake cutting part of it. That's an important event. And how did Google do this? So they basically took thousands and thousands and thousands of videos, and they got a bunch of photographers and video editors and asked them to label this as good or bad scenes, right? So pathetic to very interesting videos. And then they learned from that. They took all that data, and then they built an algorithm that the camera can use to detect interestingness of a scene, right? Now, what's fascinating about this? What's fascinating about it is not what it's doing. I know what's going in your head at this time as well, right? That thing is constantly seeing us, right? That thing is constantly going to be recording everything. Of course, it doesn't store everything. It just stores interesting stuff. But God knows what it thinks is interesting, right? We'll come to that. I mean, the rest of the session is all about that. But what's fascinating about that camera is all of that happens on that little device. It doesn't need to connect to the internet, right? Imagine the computation and the algorithmic power we've packed into a 2-inch by 2-inch camera. So there's nothing fascinating about recognizing objects in an image and recognizing scenes. We're doing that quite well today. All of that is packed into that little camera. And Google did a new release, an update on this. It said now it can understand kisses and hugs and dancing. So if you bust into a dancing move and you're worried about not being in the photo or in the capture, the camera will take care of it. Right? And that's how far we've gone with image recognition. Take a look at that. A bunch of celebrity photos. How many do you recognize? 1, 2, 3, all? The answer is none. Those were all artificially created images. Look how good they look. It uses a technique called GANs, or Generative Adversarial Networks. Sorry, data scientists, if you're in the room, I'm going to make this simple. What it does is 2 computer programs are pitted against each other, right? One called a generator generates a picture, in this case, an image of a person's face. And the other program called a discriminator says if that's good or bad, or in this case, fake or real, right? So the first one says, okay, here's a picture that I think is a good celebrity face. And the other one goes, no, not good enough. Here's another one, that's good enough. And they go on in a loop until they come up with such startling output. Look how good they are. There are problems with it. If you look closely, his ears look funny. The lady's eyes are a little asymmetric. But then, this is where we're heading, right? And if pictures can speak 1,000 words.
Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources.
Using the same technique, you can manipulate video and audio. And that's like you're superimposing voice and facial expressions on an existing video. That's how good it looks. And that's on YouTube. It's all over the place. You can actually, there's lots more. There was one recently from the Golden Globe Awards. You have to just Google this and watch them. You see the problem with this, right? The problem with this is you can create some really, really good-looking, authentic-looking videos, and these are very provoking. The kind of repercussions these will have at a political level, at a national level, is just, you can imagine that. I think the biggest problem of our times is disinformation, right? We not only know, there's so much fake news, not just about the fake news, we don't know what's authentic. So if a video like that comes out, you start to doubt authentic videos. You start to doubt authentic news. So that's our biggest problem. And the technology that I just spoke about, GANs, all you need is a laptop and access to internet. It's that easy. And there are apparently people offering services to do that on the net. So you can actually commission a deep fake video, and that concept is called deep fakes, right? We'll keep going. Who's heard of Sesame Score? Awesome. Sesame Score, this is straight from a Black Mirror episode. It's China's social credit score, right? It was created by an affiliate of Alibaba called Ant Financials. I'll just move taking pictures. Called Ant Financials. It was originally created for credit scoring, who should get a loan and who shouldn't. But now China has just gone on this Big Brother style countrywide people monitoring and social engineering. So it computes a score between 350 to 900. It takes a few things into consideration. Your financial capability, your financial status, your fulfillment capability, your identity characteristics, your social behavior, and so on. And then it gives you a score. And depending on what your score is, a good citizen will now have access to premium services. They don't need to line up in a queue for a service, for example. They don't need to put a deposit to rent a product. A bad citizen, on the other end, could be stopped from accessing certain services. They cannot buy houses in a certain locality. Their kids can't access certain schools, and you can't even on a dating site. They wouldn't even pair you up with the good citizens. So, and there's a really ugly dark side to this as well. One of the things it uses is your social affluence, your social circle. So you'd want to stay far away from people or not mix with people who have bad credit scores. In the social setting. And that's straight from the Black Mirror episode. I don't know if you've seen Nosedive. I think it's the first episode in season 3, I think. And that's real, and that's happening in China. You can go and Google Sesame Score or credit score, and you'll bring that up. Now you see, you saw some really good examples of putting AI into some really good use, really powerful use. But you also saw examples of how we can use technology to do really bad things, right? So I'll talk about what's irresponsible in the AI world, and then we'll spend the rest of the time talking about responsible AI. So using AI to create false information is irresponsible, right? Using AI to do a mass citizen scoring and social engineering without consent is bad use of AI. And offering services to create harmful AI is also bad. Right? But I'll tell you what is also irresponsible. Knowing what this technology can do and knowing how this can change human lives and knowing how we can solve previously unsolved problems for humanity is also, and not using it, not leveraging it, is also irresponsible. Right? So we've got to get this balance. We've got to get this balance right. I'll talk about a few risks associated in the AI world. I will not be able to cover all aspects of it, but I'll touch on the major risks, if I may. Bias is the poster child in the AI ethics world, in the irresponsible AI world. This is the first thing you talk about. I don't know if you heard about this. Amazon built an AI-driven recruitment tool. What this could do is it could just ingest, it could just process a lot of CVs and then score the candidates from 1 to 5, like the star rating, exactly like what Amazon does with the shoppers online, and then it would do a best job fit, right? It's a holy grail in the recruitment world. That's what they wanted. That's what they've been waiting for. Oh, I could just give it 100 CVs and then it tells me the 2 candidates that's most fit. However, that engine did not like female candidates. So it favored male candidates over female candidates. I must give credit to Amazon. They quickly pulled that out. They did not put that to use. But it just goes to say, we know our tech industry is male dominated. Do you recognize that picture? That's from Silicon Valley. That's from Silicon Valley, the series. And what's odd about that picture is, and that's a typical Silicon Valley team. Right? What's odd about it is there's no women in that picture, and that's the tech industry for you. Now we've been living in that world and we've been operating in that biased world. It was always there, But now we are encapsulating that. We're putting that into a machine, and it's going to live there for much longer. There's a few more examples. There's a few more cases that I would like to touch on. This was the first AI-judged beauty contest. It's a company called Beauty.ai did it, right? So there were about 6,000 applicants from 100 different countries, and it decided who was beautiful. 44 winners. You can actually go online and look at the 44 winners. Most of them were whites, white faces. There were one or two Asian faces in there, but there was just one sort of dark-skinned person there. So this engine completely neglected dark people as being beautiful, right? And there's more. This is another a Minority Report-esque styled crime AI engine that accused black offenders as higher risk. And then I don't know if you've heard of this. Google Photos. This made some news as well, right? It started tagging people, Afro-Americans, as gorillas, and that's because of the data that the system was trained on. That's because the data that the world had for the machine to ingest and learn from, and that's what it learned. All it's showing is what was always there. It's just becoming more evident now. It was okay it's not okay, but it was sort of all right in a sense when this was happening in the human setting. But the moment the machine started to highlight this, it's a much bigger problem. It's sort of surfacing, right? It's more than age, gender, and ethnicity. Who's heard that news? Anybody? So one night, this woman woke up in the middle of the night having her hair eaten by a robot vacuum cleaner, right? There was no malicious intent. The robot was just doing as it was programmed to do. And that's the problem. It was doing exactly as it was programmed to do. It never thought that people could also sleep on the floor and not on a raised bed. So that aspect of the cultural setting wasn't taken into consideration when that product was designed and built. Yet that product went into a culture where it is being used. Right, so the bias is beyond ethnicity, race, and gender. There's also cultural aspects to it. Have a look at this picture. What is that? What are the first things that come to your mind? Shout. Dracula. Well, okay, good. Love, war, liberty, love, romance, union, sailor, nurse. Now, what sense you make out of that photo depends on who you are as a person, where you were born, where you grew up, what system of education you went to, where you've traveled, what you've learned when you traveled, the people you've met. That is how diverse. That is, in this room we've got so many different. Someone said war. I don't think many people would have had that when they saw the thing, and that was a pretty apt thing. That was the Union of the end of the World War picture, the famous Times Square photo, I believe. So there's many aspects to bias as well. There's the human bias, the name, age, and gender, and then that doesn't change. It's immutable. And then you have the cultural diversity. Right? Depends on where you grew up and what religion you follow and what ethics you follow. And then you have systems diversity as well, right? What kind of systems did you grew up in? Was it a communist setup that you grew up in, or was it a democratic state you grew up in? All of that matters to interpret that picture. So if you're building an AI system, and that's for the mass public, then the mass public have to be considered. If some group of people are neglected, so if you neglect a bunch of people that could possibly sleep on the floor, then you neglect that person, and that doesn't work for them. Right, so diversity bias and diversity is a massive concept. I mean, that needs a day-long session in itself. But we're seeing all of that happening in the AI world. It's all surfacing up now. And then there's the ethical concerns of AI. So I'm just going to use the famous autonomous vehicle ethics right? I'm going to use this. I mean, this applies to anything AI that you build and develop. But this is something we all can understand and we can relate to. So we know autonomous vehicles, from car crashes, millions of people die every year. And industry experts and research also tells us that that will be reduced by 90% because most of the car accidents are due to human error, and we can completely get that component out with autonomous vehicles. But autonomous vehicles also poses some ethical dilemmas, right? There was a recent incident where an autonomous Uber car went over a lady and killed her because the sensors in the car didn't work and there was fog in the scene or whatever. So there's this famous autonomous vehicle ethical dilemma, right? And the dilemma goes like this, right? So you have a car approaching a group of pedestrians, right? And the car has had a malfunction. The brakes don't work. It's about to hit the group of pedestrians and possibly kill a few people, right? The car also has an option to swerve left and hit a bystander and kill that person, but save more pedestrian lives. It also has an option to hit itself into a building and possibly kill the occupants of the car, right? So what must the car do, right? That's a big dilemma. That's far from being solved. Many countries are approaching that differently. This was posed to so MIT did a survey. So they asked this question to some American citizens. And the survey results were very surprising. So most of the respondents, sorry, I just skipped something. So there were some objections from that dilemma. When this dilemma was first put into the public, people had objections. They said that's too simplistic, that's unrealistic, it's astronomically rare, it's technically not feasible, and all of that. Understand, accidents is a complex scenario. There's lots of uncertainties. There's lots of things that go into an accident. And every accident is a fingerprint in itself. You cannot just completely replicate it, right? But they were taking this too literally. They were missing the point. The point being, we now have to the machine has to make a moral decision, and therefore it has to consider some trade-offs, right? That's the point, and it is our opportunity now to influence that decision, right? So, and coming back to the survey, so MIT did a survey, and they asked people, they posed this ethical dilemma to them, and they recorded their answers, and the results were very surprising. So most of them said they will never buy a car that might sacrifice them in a certain event, right? But they also said they wanted other people to buy a car that might kill them in order to save more lives, right? You see, your whole perspective change as a consumer and as a citizen, right? So we started with an ethical dilemma, and then we've gone into a social dilemma. The same people were asked, what if there was a third-party regulation in place? What if the government regulated the cars so that the cars do exactly what is appropriate in a social setting? And they surprisingly said they will still not buy the car that is regulated, which might kill them in a certain condition, right? So it's a meta dilemma. And this is far from solved, like I said, and therefore it's a dilemma. But there are some ways... There are some ways you can get involved. I don't know if you've heard of Moral Machine. So this is another website MIT put together. I've got all these links at the end of the slide, and I'll find some way to distribute it to you guys. So Moral Machine, basically you can go to Moral Machine, and then it generates random dilemmas. And you can answer. So it just generates random stuff. It can put kids in the mix, prams, homeless people, all kinds of scenarios, and what would you want the car to do? And this website has got about 4 million visitors, and they have attempted 37 million dilemmas. So you can go and contribute to that. So if you have, that is your opportunity to go and have a say in what's happening there. And many countries have solved this differently. Germany, for example, have put together an ethics council recently, made up of ethics leaders, industry leaders, religious leaders, and all of that. And they have come to a certain conclusion on the autonomous vehicle dilemma. And you can go and read about it. So they have a set. They've come up with a conclusion, and they published that. Another thing in the AI world is, you remember deep learning, when I showed you that big spaghetti network, right? And I said there could be many, many layers, right? Most of those middle layers are hidden. It's hard to look into them and hard to go to that little node that does and find out what it's doing. It's hard, but it's not undoable. You can do it. It's hard. It's just hard. For ethical decisions to be made, the path to the result of the AI output should be known, and we should be able to trace that. So there's a concept called transparency in the machine learning space, and these models that we create have to be transparent. You have to know what goes into processing a certain process, right? So if, for example, if my insurance claim had a certain decision and it was carried out by an AI-driven process, then I, as a customer, would want to know what went into that process and why the decision was made. And the organization, as the owner, the custodian of that AI-driven solution, should be able to provide that to me. I'm just going to summarize with what we've just sort of touched on now, right? It's not easy. There's many more aspects to this. There's safety of AI and control of AI and all of that. But roughly, this is what it is. So a fair AI systems must be fair. So individuals or groups of individuals should not be systematically disadvantaged. And if they are, it must be justified. And the data and the models used in these programs must be regularly validated for accuracy, relevancy, and unintended bias. They must be ethical, aligned to some kind of an ethical standard, an organization-wide ethical standard. And then at least it must be held at the same level ethical standard as a human-driven decision. AI system, companies producing AI-driven solutions or software must be accountable. They must be accountable for not just internally developed solutions, but also what they've procured from external sources. They must understand these models. And it must be transparent. So transparency is like sort of twofold. Firstly, I need to know if I'm talking to for example, if I'm talking to an AI-based customer service, I need to know that I'm talking to an AI machine. We sort of touched on that, Richard. When the Google Duplex thing was shown to the world, there's this phone call that's made to an appointment booking, hairdressing appointment booking, and the system that at the other end is an artificial intelligence system. It is so real, so close to a human that you will not know that you're talking to an AI. Now that must be disclosed, right? So that is a transparent AI, as well as being able to interrogate these models. So what can you do? What can all of us do? Firstly, I think we have to be skeptical. We have to stop believing in the Hollywood themed definitions of AI. We have to understand what AI can and cannot do, at least at a very basic level, right? There are umpteen number of online courses, non-technical courses that everybody can go through and educate themselves on AI. There's something we should learn from Finland. So Finland did this thing called 1%, the 1% program. So their mission was to educate 1% of the population on basic AI knowledge. This could be everybody, doctors, lawyers, everybody from all aspects. And they went about that by creating a course online, and the course is called Elements of AI. And it's a very simple course, and hundreds and thousands of people have taken that course already. Right? So we must educate ourselves, at least at the basic level. ACS did they produced a starter guide, an AI starter guide. Fantastic. It has absolutely fantastic content. I use some of that content for my talks and presentations as well. So if you haven't seen that, you should go and download that and see it. And then we'll have to learn about job disruption, right? So this is the first thing. It's almost the same sentence as anything AI we talk about. It also talks about job disruption. there will be job displacements, there will be disruption to certain industries, but we have to go and understand which of those jobs are going to be disrupted and what are the new jobs that are going to come about, right? There are jobs that we can't imagine, right? So someone in the room could be a future AI transparency ethics expert, right? Or an AI model auditor. If you look at it, the auditing in the finance world has defined roles, and people go to school and study to go and become an auditor. We will have similar roles. We'll have similar jobs in the AI market. And then to be curious, right? So we'll have to first of all understand what is not default. It is not default that all people sleep on a raised bed. If you're in the business of building a solution for all people, then that's not default. So you've got to constantly ask yourself, what is not default? And we've got to recognize data monopolies. We'll have to constantly know if too much data is in the hands of very less companies. We have to know about that. We can't do a lot about it, but we have to be aware of how that data is being used. So if you upload a picture on Facebook, we know that Facebook can understand a lot from that picture, and we have to know how they can possibly use it. So just that awareness, and then you can get involved. So there's a lot of I don't know if you've heard of Asiloma principles, if you've heard of partnership on AI, OpenAI, that is sort of Elon Musk talks quite a bit about it. You can go, these are all the frameworks that are out there, and these are all codes that are being created. And most of these websites will have an option for you to go and have your say on it. So you must know about these frameworks. At the end, I have a list of all the frameworks and the principles. So when you do get that slide, you can actually go through them. And we got to stay in tune with what's happening in Australia. So the last budget, we set aside $30 million to create an AI roadmap and a strategy. We got to know what's happening there. We haven't set the roadmap as yet. We do not have an AI strategy as yet, but that's happening. So even tomorrow, for example, there's a gathering in Sydney where they're going to talk about that. So you got to stay in tune with what's happening here as well. There's lots. All of the big corporations are also coming forward to create an ethical code for us, a countrywide ethical code. And then you can bring AI into your world. Once you understand AI, take it to your world. Your world could be the world of finance. Your world could be teaching it in a school. So then you can talk to people about this. Unless we have a critical mass of group of people, AI-aware people, it's hard to form a discourse, hard to form a public discourse. So we need to know at least the basics of what this technology can do. As an organization, so this is not, this is from Accenture's Responsible AI and Robotics framework. You can download this from the net. So basically it says if an organization set up an advisory so that can foster the discussions in this space, and then you can publish that to show initiative, and then you can participate in development codes internationally, and developing industry-specific codes in the AI spectrum. So all of this is on the net. This is not, I've just put this in the slide. You can go to Accenture Responsible AI and Robotics website and lead that and have a look at that. And if you're an engineer, if you're in the business of developing AI systems, go and have a look at human-centric. I mean, make sure that the AI you design and develop is human-centric. Lots of information in this area as well. So Google, if you go to Google's sites, there's a microsite dedicated for human-centric design. So Google's people and AI research group called PAIR, they have a lot of information on human-centric design. And then you can, again, read up on all the ethical frameworks. And there are lots of toolkits. So the last year, there were many toolkits that were released in the market by big corporations like IBM, Google, Microsoft, and so on, where you could very easily look at what's happening in a complex deep learning model, let's say. Right? You can look for bias in data. So these toolkits was sort of the theme last year, so at the end of last year. IBM released their toolkit called AI 360. Google did their Google Fairness tool, and so on. And AI Now Institute has a toolkit as well. So you can go and play around with these toolkits. They're all open source mostly. And you'll see a lot of this. There'll be dedicated companies providing services in this space. So they will say, leave your model with us, we'll babysit it, and we'll go and check for bias, we'll go and check for, we'll make it transparent, we'll give you a report on what your model does. And then there are checklists, there are data checklists, so there's some there. So look, our partnership with machines is inevitable, right? Our partnership with machines is the future. There's no doubts about it. We will be working alongside machines. And for that future to work, we'll have to humanize the machines. Because if we don't make them behave like us, not just think like us, but to be ethical like us and to be moral like us, we will have to become like the machines. So we will have to machinize ourselves. Thank you for taking the time on a Wednesday evening. I hope you found it useful.
Thank you. Now I'd like to open up the floor for a few questions.
Oh, yeah. Dhiren, this is a great presentation, but I've got a couple of things to kind of relate to the whole AI. Back in 1993, ACS hosted an ethical symposium. That time, it mostly was around data.
Yeah.
And the security of data and all that came into focus and nothing else. AI was not even anywhere in the horizon. Now we are here, okay? Mm-hmm. And AI is in the focus. And my question is when AI is in a device and it is being kind of like if robots or whatever you buy, who is liable for the malfunction of AI? It doesn't matter whether it's ethically or any other economically or whichever way you look at it. Who's going to be liable for it?
Yeah, that's a good question. I mean, that goes back to accountability, right? So if I'm a car manufacturer and if my car malfunctioned, I as a car manufacturer, I am responsible for that, irrespective of all the million components that's gone into my car, right, where I've sourced the model. So it is, if I'm a financial institute and I came about a certain AI-driven decision, then it's not okay to say, sorry, Gov, the machine did it. You have to take complete responsibility and accountability of that. So that's the accountability aspect of it. It is the companies that are going to give you that service. They could use another partner. They could use another AI partner. See, up to now, AI is still a sort of a servant to humanity, right? At this stage. It'll be like that for much longer. You have to make sure that you are responsible. You are the boss. So when you're using that service and you're going out in the market, you are responsible for that. So that's the whole accountability. So on the device, if the device malfunctions, it is the manufacturer of the device. It's as good as any consumer product.
Does the device gives you a false advice?
A false advice. Again, the company providing the service, but the false advice, it is not right for the company to even bring that into the market without substantially testing it, right? So let's look at the drug industry, right? So what if a certain drug that I bought didn't work, right? How did it go through the approval process? The drug, there's a lot to learn from the medicine, the bioethics field, right? So before a drug is created and it's coming to the market, it goes through two kinds of tests, right? It goes through a safety test, is that drug going to kill people? And then it goes through an efficacy criterion, right? So it goes through, is it going to do what it says it's going to do on the label, right? And then who's responsible if your drug malfunctions? It's the same concept, but we don't have these disciplines in place. It's just a matter of time when these will come in. That's okay. We can just scream.
Thank you for a wonderful presentation from the smorgasbord of AI. 3 comments, not questions, comments. First of all, fairness. It's a great ideal. I can't imagine the military organisations around the world signing up to that one. Transparency. I look forward to seeing when the dating sites and the Lonely Hearts sites actually confess that you're talking to an AI algorithm.
Right.
That would be interesting.
Yeah.
And the third one was around the is it the choice made about whether you hit a pedestrian or hit many pedestrians or running
Ethical
a wall?
dilemma. Yeah.
That's an interesting concept because that exists right now. Everyone who gets
Yes.
their license has to,
Yes.
or doesn't have to answer that
Yeah.
question, but is potentially in that situation.
Yeah.
We don't know and we don't even ask what
Yeah.
they would do. All we're doing now is because we've got an AI algorithm to make that choice, we're transferring that choice. Now we start to think about it and talk about it. And you say that machines, we need to make them behave morally responsible. Well, we don't always behave morally responsible ourselves.
Well, we've sort of we've approximated that. So exactly. So we've sort of built some level of trust with the humans, right? So if you look at my day, I started my day in the morning, and I went and I made toast. So I plugged in the toast. It didn't kill me. The socket didn't malfunction. I didn't get electrocuted. I made my toast. I came and got my coffee this morning at Docklands. The coffee didn't kill me. The coffee did not poison me. I just trusted that this person who made my coffee didn't want to kill me, right? And then I crossed Elizabeth Street, and then I know all the cars going by, they're not going to hit me. All they have is a set of traffic lights and some white lines. But I trust that. I trust that system. There's a web of trust happening there, right? And I'm okay with that. But the moment I know that one car doesn't have a human in it, I do not trust that yet. And for that trust to happen, it's just a matter of time. And you're right, spot on. I mean, we'll have to get into that, and that will be the case.
Thank you. One more question, just over here.
Hi. So great presentation.
Thank you.
Thanks. One thing that comes to mind is combining all of those cognitive capabilities that you showed. So speech recognition, visual, hearing, the ability to debate, all of that, if combined, could take us to general AI, general purpose AI, which would be like what things like that are what Elon Musk are afraid of.
Yeah.
Do you think we're too far out from that, or is it too far-fetched? Or
Yeah. Look, there's no definite answer. In fact, nobody knows that for sure, right? We're heading towards general AI. If you look at general AI, if you look at intelligence, right? If you just measure it with one dimension, let's say IQ. So rats have a certain level of IQ, and then probably dogs have another level, more level of IQ, and then people like me have a certain level of IQ, and then people brighter than me, like you guys, have another level of IQ. So that is how we measure intelligence, right? But intelligence is just a bag full of multidimensional things that's happening there. It's like a big orchestra. The squirrel has very low IQ, but it has better long-term memory than I do, right? You take a dog, it's probably got better audio signal processing than I do. So they all have different intelligences that are better than what we do. So general AI is basically a big mix mash of all of these things coming together, right? So we don't know how far we are from general intelligence. We are heavily focused on narrow AI, and that is how we will be focused for a long time. And even when we do have general intelligence, general AI, we don't know how that's going to pan out. We can't really put a finger and say this is how the world is going to be with general AI. So, but having said that, it doesn't mean we can just completely brush that off and ignore that. We have to start. I mean, what we are doing with responsible AI and ethical AI is in contribution to general AI. But I personally think we're quite far from. It's a far-fetched concept. We're getting there. We're going down that path, but it's a far-fetched concept. That's my personal opinion.
Thank you so much for joining
Thank
us
you,
today.
Maria.
Thank you.
Thank you.
Small token appreciation.
Thank you.